Pre-Calc 11, Chapter 6.3, we're going to look at radian measure just a little bit more carefully. And the definition of a radian is the ratio between the arc length and the radius. So this is a natural measure, unlike degrees where it's an arbitrary measurement made up. So if we take a look at the arc length and divide it by this, we get the radian measure. If we look at the circumference, that's all the way around. The formula for circumference is 2 pi r. Now if we take c divided by r, we get 2 pi. And so it's natural that going all the way around for an angle measure is going to be 2 pi radians. So 360 degrees equals 2 pi radians. And when we're doing our conversion, we take 2 pi over 360 degrees times 30 degrees. But if we cancel out a 2 from here, we get 180 degrees. That's why we always do pi over 180. And 30 divided by 180 reduces this to pi over 6. So we have 270 over 180 pi, and this reduces to 3 pi over 2 radians. We can take negative measures as well. So negative 135 pi over 180, and this simplifies to negative 3 pi over 4. And finally, if we have 720 pi over 180, that equals 4 pi. So that's twice around. Now, it doesn't matter whether we put the pi after the fraction or as part of the fraction, it all means the same thing. So let's look at angles in standard position again. We have the initial side. We have the terminal side. And here we have 30 degrees. And again, it rotates counterclockwise positively. And if we go backwards, that's negative, and that's clockwise. And we are free to choose our angles going around the circle as many times as we want. But every time we go around the circle counterclockwise, we add 360 degrees to the angle. So if we add 360 to this new standard position angle is 390 degrees. So we can use this degree measure or radian measure to measure how many times we've gone around something like a Ferris wheel or a bicycle tire spinning around. Now, every time we go counterclockwise, we subtract 360 degrees. So if we were to go from here to here, this standard position would be minus 330 degrees. And anytime two angles have the same terminal arm, then we say they are coterminal. So, for example, 30 degrees and 390 degrees are coterminal. And every angle has an infinite number of coterminal sides. And we can write this down as a simple formula. And we always put the principal angle first, plus 360 degrees, n. And n being the set of integers. And it's customary to use the principal angle, because if we use 390 degrees, it's just a little awkward. We don't know what quadrant that's in without doing a little bit of math. So if we were to find two more coterminal angles, I already found one, which is minus 330 degrees here. So we can start with 390 degrees, add 360 degrees, then we get 750 degrees. We can start with negative 330 degrees, subtract another 360 degrees, and we get minus 690 degrees. Okay, so we have special angles other than 45. 30 degrees is a special angle, and 60 degrees is a special angle. And the reason for that is the sine of 30 degrees is 1/2, and that makes it easy to calculate cosine, which is root 3 over 2. And cosine of 60 degrees is 1/2. So the sine value of 60 degrees is root 3 over 2. And because these are the opposite and these are simple numbers, these are angles that we should memorize. And in terms of radians, we have pi over 6 and pi over 3. And the tangent value is also easy to calculate. And the other special angles we should know are 0, 90, 180, 270, and 360. And it gives us zeros, ones, and negative ones, and also undefined. So they're not difficult to remember. You should remember these as your reference angles, and then you can find sine, cosine, and tangent of these standard angles using these as your reference. So here's an example. State the primary trig ratios for 210 degrees. We should note that this is in quadrant 3 right away. So our standard angle is 210 degrees, and our theta prime is 210 degrees minus 180 degrees. That gives us 30 degrees as our reference angle. We should know that sine and cos are negative in quadrant 3, and tangent is positive in quadrant 3. So sine theta is negative 1/2, cos theta is negative root 3 over 2, and tan theta equals y over x. So that's negative 1/2 over negative root 3 over 2. So that just leaves us 1 over root 3. And that completes this lesson.